Hello everybody, welcome to another video lesson. Today we're going to go over adding and subtracting rational expressions. That is our one objective, to determine the least common multiple of a polynomial, and then we're going to add and subtract rational expressions. So let's hop right into it. Okay, first things first, least common multiples of polynomials, right? So when we factor our denominators, our least common multiple is going to contain each factor the greatest number of times it appears as a factor. Now, if you guys remember here, we've got our 10 over 15, and if we add 3 over 9 to that, okay, you guys can find the least common multiple of 15 and 9, those are our denominators, right, by factoring out 15 and 9, and you guys often do this in your head, but we would say, okay, I've got a 5 here, and 3 appears twice when I factor out 9. So I would say our least common multiple would be 5 times 3 times 3, which would be 45. Now, similarly, if I have some polynomial, some rational expressions here, we would go ahead and again, we would factor out our denominators. Okay, so we've got y squared minus 2y minus 8, and that would factor into y minus 4 and y plus 2. And we could factor out the other denominator as well into y plus 2 times y plus 2. Now we'll go ahead and take, since y plus 2 occurs twice in the second denominator, we would take both of those y plus 2's, and we'll take the y minus 4 as well. And our least common multiple for these denominators would be y minus 4 times y plus 2 quantity squared. Okay, so that's our least common multiples here that we're going to use to add and subtract our rational expressions. So just generically, if I have x over y plus a over b, then our least common denominator then would be y times b. Okay, so now I need to think, how can I express each of these terms with the denominator y times b? What am I missing in this first term? Okay, well, I've got an x in there, but I need to multiply by b over b in order to get yb in that denominator. So my numerator then would become xb, and in my second term, we are missing the y from our least common denominator. Okay, so we're missing that y, so we would multiply by y over y, just like that, and our numerator would become a y. And now once we have our rational expressions looking like this, we can go ahead and combine the numerators together under one denominator, which would just be our least common denominator of yb. Okay? And same thing when we are subtracting rational expressions. Again, my least common denominator, if I'm subtracting these two terms, would be yb. So now I need to think again, how can I express the first term in terms of yb as the denominator? Well, I'm missing a b, so I would multiply by b over b. And that would give me, again, xb in the numerator, minus, and then I'm thinking, how can I express the second term with a denominator of yb? And I'm missing that y again, so I would multiply by y over y. And now I can combine my numerators here and all over one single denominator of yb, so I'd have xb minus a y here. Okay, so that's our concept for today. Let's get into our examples here. Okay, so for our first example here on the left, what is our least common denominator? So let's look at each one of our denominators individually. So we've got 7 times y and 3 times y. So those can't really factor those. It's just 7 times y and 3 times y. So we're going to go ahead and take the 7, the 3, and the y here. And let's see, so my least common denominator would be 7 times 3 times y, which is going to equal 21y. So now let's take a look at my first term here. We've got 6 over 7y. What are we missing from this denominator to get the least common denominator? Well, we're missing this 3y, right? So we'll go ahead and multiply by 3 over 3. And then we'll take a look at our second term, 2c over 3y. What are we missing from this denominator that would give us the least common denominator? That's our 7 here. Okay, so I'll multiply by 7 over 7. And now I can express both of these terms as 18 over 21y and 14c over 21y. Now we can combine our numerators under one single denominator, or over one single denominator, and we would get 18 minus 14c all over 21y. All right, now let's take a look at our example here on the right. We'll go ahead and again, same process. It's just a little bit more complicated with our polynomials now instead of dealing with monomials. So we're going to go ahead and factor out both of our denominators. So we get a plus 3 and a plus 4 for the first term, and a plus 4 times a plus 5 for the second term. So what do we have here that would give us our least common denominator? We have a plus 3, a plus 4, and a plus 5. Now notice I have an a plus 4 in each of these. I do not need to take a plus 4 twice. Okay, that's what our least common denominator's definition is. I just need to take this factor the most amount of times that it is seen in a denominator, which in this case is 1. So I just need to take 1 a plus 4 in this case. Okay, so now let's take a look at our first term and just leave it in factored form once you get it factored here. Okay, no need to put it back into a squared plus 7a plus 12. Just leave it in factored form, which you already found here. So I can say, okay, what am I missing from my denominator here? Well, I'm missing a plus 5. So we'll go ahead and multiply by a plus 5 over a plus 5 and minus our second term, which we've factored again. What are we missing? We're missing a plus 3. So I'll multiply by a plus 3 over a plus 3. And we can go ahead and distribute my a and distribute my 3. And what do we have? We'll have a squared plus 5a minus, okay, now don't forget, when we have a minus here, you are subtracting this entire numerator here. Okay, so if it's helpful to put parentheses around here and then think of distributing a negative 1, that's what I would suggest. So we would kind of distribute a negative 1 here, and that would give me minus 3a minus 9. And when we combine like terms, that would give me a squared plus 2a minus 9 all over my least common denominator. So that's how we would simplify this expression here. Okay, second example. Now we have polynomials on top and bottom. Again, so we'll go ahead and find our least common denominator by factoring. What do we have here that gives me the least common denominator? That's going to be x minus 3, 5, and x plus 2. So that would be my least common denominator. Take a look at my first term. What am I missing that gives me this least common denominator in my first denominator? That's just a 5. So we multiply by 5 over 5 and subtract our second term. Again, what are we missing from this least common denominator? We're missing an x minus 3. So we multiply by x minus 3 over x minus 3. And from here, we can go ahead and combine these under one fraction or on one fraction. And we just multiplied this 5 throughout, and we multiplied this 4 throughout, so we could combine like terms like so. And don't forget, you are subtracting the entire second term here, so the entire second numerator should have think of this as a negative 1 out in front of it, and when you distribute that, that's going to change your signs. And when you combine your like terms, we get x plus 7 all over your least common denominator. All right, let's take a look at one more example here. We've got our least common denominators. When we factor each of our denominators individually, we get 4x plus 1 times x plus 5, and we get 3 times 4x plus 1. So again, we've got 4x plus 1 in both of our denominators, but we only need to take 1 because it's only seen once in each of the denominators. Okay, so these 3 terms would make up my least common denominator. And we can go ahead and take my first term. What are we missing? We're missing a 3, so we multiply by 3 over 3. Take my second term. What are we missing from our denominator? We're missing this x plus 5. So we'll multiply by x plus 5 over x plus 5. And we can go ahead and start multiplying through. So I'm going to distribute this 3, and I'll distribute this 6. And that's how we get this in my numerator, 3x minus 24 plus 6x plus 30. And start combining my like terms, and I get this here. Now, keep in mind, I can factor out a 3 here, right? Factor out a 3 out of my numerator, and when I do that, I'll have a 3 that cancels in the numerator and denominator, and we can further simplify this to 3x plus 2 all over 4x plus 1 times x plus 5, all right? So look out for additional simplification that you can do here in your final once you've combined like terms. All right, now we're going to take a look at complex fractions. Don't get confused with these complex fractions. All this is, remember, we're going to take a look at the top and the bottom separately, okay? So let's take a look at this top, I guess we would refer to this as our numerator here. So we have 1 minus y over x. So let's find the LCD of the top. So I've got a 1 and an x here. So the LCD of the top, or my numerator, would just be x. Now let's take a look at the bottom, the LCD of the bottom. I've got a y and an x. So we just multiply those together to get the LCD of the bottom. So that's going to be yx or xy. Now again, taking a look at the numerator separately, we have 1 over 1. Okay, what are we missing from this denominator to give me my least common denominator? We're missing an x. So let's multiply that by x over x minus y over x. And our denominator is already x, so we're good there. So that's going to simplify to x minus y over x. And then my denominator, I'll take a look at my first term. I've got 1 over y, and we're missing an x here. So again, we will multiply by x over x, and we will add then our second term, 1 over x. We're missing a y in our denominator, so we'll just multiply by y over y. And that term would simplify to x plus y over xy. Now we can go ahead and write this as a simplified complex fraction, and we can think of this as multiplying by the reciprocal of my divisor here. Okay, so I'm just going to take this divisor and flip it, and then we can multiply straight across. We can see that we've got some x's that cancel out, and we can go ahead and write this in its simplified form like so. Okay, so using this exact same process, go ahead and see if you can simplify, pause the video, see if you can simplify this complex fraction here on the right. All right, here is the process for that. We should end up with c plus d times c minus d all over d times d plus 2c. Okay, so let's move on to our last example slide. Again, we're working with some complex fractions here. We're just going to look at the top and the bottom. Again, trying to look for our LCDs. So for the top, we get x. For the bottom, we get xy again. Take a look at the numerator by itself. So I've got 1 over 1. Multiply that by x over x. And I'm adding 2x to that. That's going to simplify to 2 plus x over x. And my denominators, I'll have 3 over y. What are we missing? We're missing an x, so let's multiply x over x. Minus 4 over x. What are we missing here? We're missing a y, so we're going to multiply by y over y. And that'll simplify to 3x minus 4y all over xy. So again, our complex fraction will simplify and look like this. And we can go ahead and multiply by the reciprocal of my divisor, just like we did last slide, and multiply straight across. We're going to get some x's that cancel out, and this will be my final simplified form. Okay, so using that exact same process, again, pause the video and see if you can simplify the expression here on the right. Okay, you should have gotten a times a plus b over b times a minus b. All right, so that's the process there. And that is all we have for this video. Good luck with your practice.